Your massive generative AI workflows are burning through tokens and the planet faster than most teams realize today. We are moving past bloated prompt architectures toward recursive pruning and lean context window management for real efficiency. Agentic systems that plan, execute, tools, and reason across long contexts have turned data centers into always-on intelligence factories. Global data center electricity is projected to hit 565 terawatt-hours in 2026, a 26% jump. AI-optimized servers alone will consume 175 terawatt-hours this year, growing 84% year over year. In the United States, data center demand is forecasted to reach 41 gigawatts in 2026 and keep climbing fast. The core driver is the shift from short episodic queries to sustained multi-step inference loops and constant memory retrieval. One agent goal can trigger dozens of sequential inference steps, self-correction loops, and tool calls, amplifying energy use. Large key-value caches and long context retention create continuous baseline power draw across high-speed memory systems. Power availability, not raw silicon supply, has become the primary bottleneck for scaling modern AI deployments worldwide. Token generation flows directly into hardware power draw, cooling overhead, grid demand, and finally, Scope 2 carbon emissions. Carbon emissions scale almost linearly with generated tokens and processed context length under continuous high utilization. Inference has overtaken training as the dominant source of operational carbon in large-scale deployed AI systems. Cooling multipliers and high regional grid carbon intensity further amplify the environmental cost of every inference cycle. Brute force scaling is hitting diminishing returns as energy limits, thermal walls, and memory constraints slow progress. Lean engineering prioritizes algorithmic efficiency, subquadratic attention, and domain specialization over raw model size. State space models and sparse attention achieve linear scaling while avoiding massive key-value cache explosions. Sub-byte quantization and speculative decoding deliver high throughput with dramatically lower memory bandwidth needs. High-density synthetic data and mixture of experts routing let smaller models outperform much larger ones on targeted tasks. At the prompt level, replace conversational prose with high-density semantic key-value structures to cut initial token overhead. Structured YAML or JSON-style declarations can reduce system tokens from hundreds down to roughly 60 to 120. Re-engineering open-ended chain of thought into constrained decision matrices eliminates redundant narrative reasoning completely. This approach can cut output tokens by nearly 90%, while improving both accuracy and deterministic consistency. Token-frugal design treats every computational token as a direct proxy for energy cost and carbon impact. Recursive pruning and localized memory retrieval prevent unnecessary reprocessing of entire conversation histories. Replace monolithic agents with networks of specialized low-parameter micromodels for dramatically lower energy consumption. Short-circuit loops with state hashing, error thresholds, and hard-step budgets to stop infinite waste immediately. Streamlined green systems can reduce energy per task by over 90% compared with traditional autonomous agents. Real-time tools such as CodeCarbon, Kepler, and NVIDIA-SMI let developers see energy cost as code executes. Lower inference costs protect gross margins, enable aggressive pricing, and create lasting competitive advantage. Transition existing systems through 4 clear phases: audit, contain, rearchitect, and automate with carbon-aware scheduling. Measure success with intelligence per watt metrics and continuous energy regression testing inside your CI pipelines. Lean, token-frugal modular design is no longer optional. It is the only sustainable path for scalable agentic AI. Start applying these principles today and build systems that deliver maximum intelligence per computed watt. Thank you for watching. Like, subscribe, and comment the next AI efficiency topic you want covered in depth.